Hello, future mathematicians! Welcome to another exciting learning episode. This is Teacher Marky, your soulmate and math buddy. Last episode, we were able to discuss and illustrate quartiles, decimals, and percentiles. Today, we will discuss the calculation of the position or location of a quartile. Just a simple recall, quartiles are the score points which divide the distribution into 4 equal parts. 25% of the distribution are below the first quartile, 50% are below the second quartile, and 75% are below the third quartile. Q sub 1 is called the lower quartile, and Q sub 3 is called the upper quartile. Q sub 2 is greater than Q sub 1 but less than Q sub 3, where Q sub 2 is the median. The difference between Q sub 3 and Q sub 1 is the interquartile range. Let us take a closer look at the quartiles. Since the second quartile is equal to the median, the steps in the computation of the median by identifying the median class is the same as the steps in identifying the Q1 class and the Q3 class. Let's take these considerations. A. 25% of the data has a value which is less than or equal to Q sub 1. B. 50% of the data has a value which is less than or equal to the median or Q sub 2. And C. 75% of the data has a value which is less than or equal to Q sub 3. For example, the owner of a coffee shop recorded the number of customers who came into his cafe each hour in a day. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. Find the lower quartile and upper quartile of the data. In ascending order, the data are 5, 8, 9, 9, 10, 10, 11, 12, 14, 14, and 17. The least value in the data is 5, and the greatest value in the data is 17. The middle value in the data is 10. The lower quartile is the value that is between the middle value and the least value in the data set. So, the lower quartile is 9. The upper quartile is the value that is between the middle value and the greatest value in the data set. So, the upper quartile is 14. This time, we will be using a method. Mendenhall and Sinchi method using statistics for engineering and the sciences define a different method of finding quartile values. To apply this method on a data set with n elements, first, calculate the lower quartile L, which is equal to the position of Q sub 1, which is equal to 1/4 times the quantity of n plus 1, and round off to the nearest integer. If L falls halfway between two integers, round up. The lower quartile element is the lower quartile value for Q sub 1. Next, calculate the upper quartile Q, which is equal to the position of Q sub 3, which is equal to 3/4 times the quantity of n plus 1, and round off to the nearest integer. If U falls halfway between two integers, round down. The upper quartile element is the upper quartile value or Q sub 3. So for our example data set, 1, 3, 7, 7, 16, 21, 27, 30, 31, and n is equal to 9. To find for q sub 1, locate its position using the formula 1/4 times the quantity of n plus 1 and round off to the nearest integer. The position of q sub 1 is equal to 1/4 times the quantity of n plus 1. So we have to plug in the value of n, which is equal to 9. So we have 1/4 times the quantity of 9 plus 1, which is equal to 1/4 times 10. 1/4 times 10 is equal to 2.5. The computed value, 2.5, becomes 3 after rounding up. The lower quartile value, or q sub 1, is the third data element. So q sub 1 is equal to 7. Similarly, the position of q sub 3 is equal to 3/4 times the quantity of n plus 1. So we have to plug in the value of n, which is equal to 9. So we have 3/4 times the quantity of 9 plus 1. So we have 3/4 times 10, which is equal to 7.5. The computed value, 7.5, becomes 7 after rounding down. The upper quartile value, or q sub 3, is the 7th data element. So q sub 3 is equal to 27. Now it's your turn. Find the lower, middle, and upper quartiles of the data. Screenshot the data, then solve using any of the two ways presented to you. If you are done, just comment your answer in the Google Meet chat box. Thank you for listening. I hope you have learned something in the discussion. Once again, this is Teacher Marky, your soulmate and math buddy.